We are now going to look at some problems involving hyperbolas. So just to save a little bit of time, I went ahead and we're going to start with looking at, or we're given an equation of hyperbola and we're asked to find all these things, to find the center, to find the transverse axis, the vertices, the foci, the asymptotes, and then to make a rough sketch of the graph. So the first thing you have to do is determine which standard equation we should be using. And the key for hyperbolas is what I call which is the positive term. In other words, the x squared is a positive term because we're subtracting the y squared. If you look at our formula sheet, there's two equations. This first one is where the x squared is over the a squared and it's positive. The second one is where the y squared is over the a squared and it's positive. When the x squared is the positive term, that's a left or right hyperbola. And if the y squared is positive, that's an up or down. So this is going to be a left or right, which basically it looks like two sort of parabolas back to back. So the standard equation for this is x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. So we need to determine h and k and a and b to figure out all the stuff we're asked for. Well, the h and the k are pretty easy. First of all, the center is h and k, and in this case, you notice here in the standard equation we have these parentheses, but there's no parentheses. That's because h and k are 0, which means for this hyperbola the center is at the origin. Now it's pretty easy. The 16 is a squared, so a is going to be 4, and the 9 is b squared, so b is going to be 3. Now with this information, we can go ahead and pretty much graph the hyperbola. Let's go ahead and do that, and as we do that, then we can figure out the rest of the stuff. So the center is at the origin. And what you do is, since I know this is a left or right, A is going to help me find my vertex, and I'm going to move a distance 4 to the left and the right. So these are going to be my two vertices. And then from the center, I'm going to move up and down the distance b, which is 3. And then what you do is you take these 4 points and you sort of sketch in a rectangle that connects those 4 points. And then you connect the 2 corners through the center. These lines end up being called asymptotes, which we're going to have to work with later on. Now, once you have this, since we know it is a left or right hyperbola, we can sort of have a pretty good idea of what this hyperbola is going to look like. So now, from what we've done in this graph, we can start to figure out some stuff. For instance, the transverse axis, the question is, Well, the transverse axis, you can think of it as a line that cuts the hyperbola in half. So obviously it's not going to be up and down because it wouldn't even actually touch the hyperbola. If we're going to cut the hyperbola in half, it's going to be horizontal. And the question for the transverse axis is going to be, is the transverse axis parallel to the x-axis or the y-axis? Well, the x-axis is the horizontal axis. For this one, the transverse axis has to also be horizontal. So when you're asked a question about the transverse axis, you would say it's parallel to the x-axis. If you happen to have a up or down hyperbola, then the transverse axis would be parallel to the y-axis. We can determine the vertices. These 2 points right here, from the origin, we had to move 4 to the right, so therefore that point is 4, 0. And then the other vertex, we had to move 4 to the left, so that point is -4, 0. Now the the two foci are what I call inside each half of the parabola. And the foci, we have to actually do that mathematically. Let's just go and do it. The equation for an ellipse, once again, the distance from the center to the foci is c. So we have this relationship between c, a, and b. Since we know a squared and b squared, a squared is 16, b squared is 9, we can actually say that c squared is 25, and then if we take the square root of both sides, it turns out c is 5. So the foci, we're going to move 5 to the right, and then 5 to the left. So the actual foci would be, this point is going to be 5, 0, and the other foci would be -5, 0. Now the only thing left, they want the, let me see how they word it. They want the asymptote, they want the equation. So these asymptotes are straight lines. This is going to have a positive slope because the slope of a line, if you remember from algebra, as you move from left to right on your graph, if it's going up, it's positive. If it's going down, it's negative. So this asymptote will have a negative slope. So they want the equation of this straight line. They first ask for the positive with the positive slope. Now this isn't too bad because both these lines go through the origin, there's not going to be any y-intercept. So the equation is basically just going to be y equals mx, where m is the slope. Now I don't have time to obviously reteach about finding slopes and graphing and stuff, but suffice it to say, the slope of a line is rise over run, where you choose 2 points on the line and use stair step. So I'm going to choose the origin and this corner. To get from here to here, my rise is 3, my run is 4. Therefore, rise over run is 3/4. Therefore, the equation of this asymptote is y equals 3/4 x. And if you do the equation for the negative asymptote, turns out your slope is going to be -3/4. So the equation for this asymptote is y equals -3/4 x. And then here we've already created the plot. All right, so that's all the information that they're asking about. Now here's another problem. I'm not going to do this problem. I'm just going to start it out just because you might see this. you're told this is the equation of a hyperbola, and they were asking a bunch of questions, but it doesn't look anything like the hyperbola equation, and that's because it's not in the standard form. The key thing about the standard form is this side needs to be 1. So what can I do? So this side will be 1. Well, how about I divide by 5/76? Of course, I will have to divide both sides by 5/76. And what you do is 16 over 5/76 reduces down to then minus y squared over 5/76. And then you are in standard form now. And then you can go about getting your standard equation and figuring things out. So sometimes the initial problem you're given is not in standard form, and that's always going to be the first step. All right, let's do one more. This is going to be a little more complicated, mainly because if you look here, the origin is not at the center, so that makes things a little uglier. First of all, is this equation standard form? Yes, it is. I got a 1 here. I've got numbers in the denominator here. What kind of problem is this going to be? Well, the x is a positive term, so once again, turns out this is going to be a left or right ellipse. So the standard equation for this ellipse is x minus h squared over a squared minus y minus k quantity squared over b squared. So the center, or HK, so here we go. I go grab that -7, which translates into h being 7. I go grab this +8, which translates into k being -8, right? Whatever you grab here, it's always the opposite when you are trying to figure out the center. If a squared is 49, a must be 7. If b squared is 64, b must be 8. So now, knowing the center in a and b, I can now make a sketch of this hyperbola and then try and start to figure out all the rest of the stuff. So the center is 7, -8. 3, 4, 5, 6, 7. There's the center. Now, once again, this is going to be a left or right hyperbola. Therefore, now I can step off from the center. I can step off my value of a. So in this case, 7 to the right and 7 to the left. Well, I'm sitting here at 7. So if I go 7 to the left, I'm right here at the y-axis. If I go out here, I'm like at 14. And then if I step off the B, I have to go 8, which takes me back here, and then so now I can draw my rectangular box. Try and draw these asymptotes. And I know the hyperbola is left and right. So now I can try and start to figure out some of this stuff. For instance, they're going to ask about the transverse axis again. Once again, this is another, it's going to be parallel to the x-axis. The vertices, well, this center here is 7, -8. And I moved 7 to the right, so it's supposed to be 14, -8. When I move to the left, 0, -8. So I guess I can say the vertices 14, -8, and 0, -8. Now the foci, of course, you have to do it mathematically. C squared equals A squared plus B squared. A squared's 49, B squared's 64. Looks like C squared is 113. So C then is going to be the square root of 113. So once again, that's the distance you're going to move from the center to get to the foci. So the foci are going to be in each side of this hyperbola. And if I want to actually give the coordinates for the foci, what you do is you're starting here with x is 7, and you're adding square root of 113 to move in the positive x direction. So we'd say 7 plus square root of 113. That's the value of x for the foci over here. The value of y doesn't change. Now the other foci do the same thing, except you're going to subtract square root of 113. So that's the equation of the two foci. Asymptotes. Asymptotes are sort of messy on this one. Last thing we have to do. Now for the last one, since the center was at the origin, it made it a pretty simple problem. This one, the center is not, so it's more difficult. We're going to end up using what's called the point slope equation, if you remember back to algebra. And that's where if you have a straight line, if you know the slope and you know one point on the line, then you can use this point slope equation. So what I'm going to do is, for the point, we'll use the center. So x1 and y1 are going to be, the center is 7, -8. Now for the slope, so there's two asymptotes. This first one has the positive slope. So once again, you go to the center, and I'm going to step off to this corner, and I realize when I go up, my rise is going to be 8, and my run is going to be 7. So rise over run, the slope is 8/7. So now I can plug in 8/7 in for my slope. I plug in 8, and x of my point is 7. Y minus y1, y of my point is -8, so if you subtract it, it's like adding it. And when I looked, they're okay with this equation right here. And then the only difference to get the other asymptote, of course the slope is going to be negative, but we're going to use the same point. So we should be able to all we have to do is change the slope to the negative, then we should be good to go. All right, pretty involved, but hopefully be able to figure it out.